All right, guys, it is Lifting Titan here with my C++ Masterclass. I wanted to get at least this first section out today just to get some feedback, how it is, how it works. And again, I'm trying to keep these under a half hour each, even if it is only for section 1.1, which is what today's section is going to be. So section 1, Introduction to Computers. Let me go ahead and switch over to the PowerPoint that I did. So we're going to go over in section 1.1, History and Components. While for programming, you don't really need to know a lot about history, I'm just going to briefly touch on this. If you guys would do more in-depth research, kind of go from here. So in 1944, IBM and Harvard collaborated on the first technical computer, which was the Mark I. And this is called digital computing, not, old school ancient, abacus and stuff like that. 1946, ENIAC through the University of Pennsylvania. 1951, UNIVAC, which was used to help the U.S. Census Bureau do the census taking. 1956, Fortran and COBOL. These were the first two early programming languages. 1970, the first central processing unit was invented. 1977, Stefan Wozniak and Steve Jobs designed the first Apple computer. 1981 was the first PC from IBM. And then, as you guys know from there, the 90s had Windows, and up to today, you guys know where we're at. This is also important to know. John Van Neumann in the late 1940s designing his computer design included arithmetic, logic unit, a control unit, memory, and input and output devices. So I'm going to go over really fast both theory and practical applications. So again, guys, I was in a comp sci program. It was all theory. There was no practical application behind it. We're going to go over right now the elements of a computer system. What does every computer have that makes it a computer? So every computer is going to have at least these four main physical components: a CPU, main memory or random access memory, some type of secondary storage device, and then input and output devices. I'm going to go over first what is a CPU. CPU is the central processing unit. It is considered the brain of the computer. It is the most expensive part to buy, which I will go into here later in this lecture. More powerful CPU and more cores equals a faster computing time, and arithmetic and logical operations are carried out in the CPU. I also wanted to touch on practical application, the motherboard. This is actually the motherboard that I have in my current computer that I'm recording this on right now. As of today, it is the #1 selling Intel motherboard on Newegg. CPU sockets into the motherboard. So if you guys see, do it in green. So if you guys see right here, this is actually also the CPU I have in this computer, an Intel Core i9. You're going to put the CPU goes right here on the motherboard. Location might be different, but usually there is a very clear indication of where the CPU is going to go. Each motherboard has a form factor that matches your PC form factor, CPU chip manufacturer, and CPU socket type. So for the CPU, is it going to be AMD or Intel? Form factor, ATX, MATX, EATX, ITX, and others. Each PC case has a certain form factor. Form factor determines input-output device ports. So on my old PC, guys, I had a smaller form factor. So this is the current input-output device for USBs, internet, sound on this current motherboard, which is one on my computer. I use a lot of stuff. And socket type varies by AMD and Intel. Let's go ahead and go over main memory now, or random access memory, or RAM. It is connected directly to the CPU. The CPU is going to use this every single time you guys open a program. It's going to load that program into memory before it can be executed or ran. All data must also be put into main memory before a program can use it. So for instance, you open Microsoft Word, CPU puts that into RAM. You type hello world into Word, that's also going to be in RAM. Memory is ordered in a sequence of cells called memory cells, and each cell has a unique location in memory called the address. And when the computer is powered off, that random access memory is wiped. Well, Marcus, what happens, when you turn off the computer? What happens to that RAM? I'll go over that here in a second, or the data. I'll go over that in a second. As of right now in 2024, RAM can be either DDR4 or DDR5. As you guys can see over here, this is also, again, the RAM I have in my computer right now. Here's the CPU, okay? And where this box is at, that is going to be where the RAM goes into. You do have to install the RAM in a certain order. Again, don't worry about that for right now. But what is the difference between DDR4 and DDR5? So my computer currently has DDR5, has a higher bandwidth and speed. It is a heck of a lot more costly, takes more power usage. You can get up to 64 gigabytes per stick. So one of these, so right here, that is technically one stick of RAM. That is then technically two. They are sold in pairs. They're meant to work with each other. So mine has 32 gigs in each stick for a total of 64 gigabytes total. 288 pins. So what that means is right here on the random access memory, when you plug it in, that's how many pins are going to be at the bottom of the random access memory. And it has its own power management. DDR4 has a lower bandwidth and speed. It is way cheaper, uses less power, only up to 16 gigabytes per stick, same pin, and relies on the motherboard for power management. So physical components, secondary storage, information, main memory is stored in secondary storage for permanent storage. So again, I just made an awesome Word document. Where is that going to be saved? In your secondary storage. Examples of this include HHDs, hard disk drives, and I'm going to go here really fast. So when we started, right, if you guys remember the old vinyl discs, right, they spin, and there's that needle that reads the sound. That's exactly what an HHD does. Think of a solid state drive as kind of a flash stick. So your SSD is not going to have any moving parts. Once it dies, though, it dies. I also put CD-ROMs on here. I know in 2024 no one uses those. Still an example of a secondary storage, and flash drives. Physical components, input-output devices. Input devices feed data into the computer. So your keyboard, your mouse, drawing tablet, webcam, scanner, secondary storage. Output devices display results from the computer, so your monitor, printer, and secondary storage. I also have over here, this is again the back input-output of my motherboard. You have your display output up top usually for most motherboards. This is not a graphics processing unit. This is the onboard graphics processing unit of the CPU. So, you're not gaming. Most business computers only use what is right here. You then have your device input output. So, webcam, solid state drives. As you guys can see, my motherboard has a lot of stuff. The only thing that is not is right here. So this is going to be your wired. Well, I cannot type. Not spell. That's going to be your wired. That is horrible. I'll have to get a tablet for this. Wired internet. This is for if your board has Wi-Fi, and audio input output. Other physical components that I want to talk about that, if you want to build your computer, you want to know about computing, that comp sci programs don't touch on. GPU is your graphics processing unit. It is a specialized electronic circuit initially designed to accelerate computer graphics and image processing, either on a video card or embedded on motherboards, mobile phones, personal computers, workstations, and game consoles. PSU is going to be your power supply unit. That is going to supply power to all of the components of your PC. And CPU cooler, cool CPU to prevent overheating and system failure. As a bonus in this first lecture, because that was only about 10 minutes, I am going to go over building your own PC using the specs and parts that I used for my own personal PC. So I'm going to go over kind of how I did it. I will link everything in the description below. So every computer is going to have these basic components: your CPU, your motherboard, your memory or RAM, GPU, case, PSU, storage, CPU cooler, and iOS. So let me go ahead and go to, I was prepared. So here is Newegg. I recommend Newegg for things. It's really good. Sometimes Best Buy will have parts cheaper. So the first thing you're going to want to look into when you're building a computer is what type of processing unit do I want? AMD or Intel, and how beefy? Again, as I just said, it is the most expensive part of your computer. This right here, guys, is actually my current CPU in this computer that I'm recording this on. It is the best Intel CPU you can get as of right now. It has 24 cores. And as you guys can see the price right here, it is $540. That is a big chunk. So, okay, I have the CPU. What do I need to know to get, my motherboard and stuff? So let's go down here to specs. So you come down here, right here. You want to look at the CPU socket type. And if you go on Newegg, it will tell you all of this. And so you want to know then, you want to know what type of motherboard you can get that has that CPU socket type. Luckily on Newegg, you can actually just filter by this socket type. I already know what it has. It's currently running in my computer. I then went with this motherboard. It's an ATX gaming motherboard, so keep that down. It also tells you it takes DDR5 RAM. As well as what type of PCI slots it has. As you guys can see, it is currently usually $300. It is on sale for $249. So then again, you also want to come down here to the specs. LGA 1700. LGA 1700. Perfect. You then want to go down to the number of memory slots, DDR5. So keep that in mind. You know you're going to need DDR5 RAM. PCI slots, these are important for graphics cards. We're going to get there later. But you also want to go down here to the form factor and dimensions, ATX. So now we know the CPU is going to fit in the motherboard. We now know that the motherboard takes an ATX form factor and only takes DDR5 RAM. So let's go ahead and look at the case then. Oh, look at this. Fractal design, ATX, high airflow compact, tempered glass, mid-tower computer case. This case is it's not that big. It's very, very quiet. I barely hear it even when things are running. And so now we know it takes an ATX form factor. And I will say, guys, this thing keeps it very, very cool. So with that being said, we now know the case we have. Let's go look at RAM right here. 64 gigabyte, 288 pin, DDR5. Now, with RAM, the average user who's just using their computer for, let's say, low-end gaming, Cameron maybe is just using it for school, you probably won't need more than 16 gigabytes of RAM. And again, in the next lecture, I'm going to go over kind of what gigabyte and terabyte and megabyte and all that stuff means. But for right now, just know that for the average user, you're not going to need 64 gigabytes of RAM. Now, I run streaming software. I game. I record stuff. I am doing, game development, 3D modeling. Right now on my computer, guys, I have Streamlabs open, PowerPoint, and 2 Adobe programs on top of Microsoft Edge. While right now recording, there is no hiccups on this computer because, again, I have really good RAM. So now you have all of that figured out. You have the bare bones. For graphics cards, this is the graphics card that I have in this current computer. Again, you guys can see we're already above, almost at $2,000. This is a really good mid-tier graphics card. Again, my monitor is only 1440p. I'm not looking to get high performance. I'm looking for a balance of both, so that was really good. Again, you guys can do research on what graphics card you want. The only thing you need to look at with the graphics card, come down here to specs. Oh, really? most graphics cards are going to be where's the PSI? The PCI. Most cards are going to fit that. So you just make sure it fits that. Now, CPU cooler. So your CPU, especially when you have a top of the line i9 like me, it's going to run hot. It can potentially overheat. This is a CPU cooler. I wish I could show you guys with the camera right now, but in my case, it is literally over the CPU. It looks like it's literally the biggest thing in the case, bigger than the graphics card. But it keeps things nice and cold. I just put my hand on the computer right now. It is pushing out cold air. So you guys will just have to do research on what type of CPU cooler you guys want. So as you guys can see here in the picture, this is going to go on top of the CPU, literally right on top of it with some thermal paste. It's going to screw in, and then this runs everything. Now, how do I know how much power I'm going to need? Well, Newegg, luckily, has all of this for you. So I'm just going to go in here. Oh, God. And basically, you just want to find your CPU. So right now, the CPU just by itself, guys, is pulling 275 watts. Motherboard, ATX. Right here again. And you guys it's so easy. All you guys have to do is just plug in what parts you have in here, and Newegg is going to do everything. So right now, 500 to 599 watts. Random access memory. So right here, you can do either 32 by 2, or you can literally just do 64 gigabytes. It's going to be the same thing. It's math. Solid state drive, I have 1 terabyte plus, 2 of those. As you guys can see, it didn't really change anything. Hard disk drive, I do have one of those installed. Oh God. I think it's in there. Again, it doesn't really change anything. So this is how you guys are going to determine what PSU wattage you want. And here's the thing with power supply. You would not want to buy one that's at 700. My one right now on this computer is this Corsair low noise ATX. Again, it says specifically it's meant for ATX. Power supply. And what it means by fully modular is that on the back of the PSU, this is what it's called, modular. If it's not modular, it'll just be one cord out to everything. But again, this is 850 watts, which for this computer is 150 watts more than you need. If you guys are ever confused on this, Newegg also on their site has a PC builder. I did do this to double check myself, but if you guys kind of do what I just did and kind of start with your, start with your, CPU and go from there, you guys should be fine. That is the end of this lecture. 18 minutes, not bad. Up next is going to be section 1.2. Thank you guys so much for watching. Like I said, these first 2 sections are going to be free. I just wanted to make sure I kind of got some things out to check. Is what I'm doing good? Do you guys like my teaching style? So thank you guys for tuning in, and I will catch you next time.